Here we are at the Byvac stand, and here's Jim Spence of Byvac.
Hello, I'm Jim, and I want to show you this, which is the Byvac PIC 32 microcontroller. I just want to show you how easy it is to use. What we've got running here is a terminal emulator running at 5200. Right now, plug this into a USB to serial interface. You can see that it comes up, as soon as I plug it in, it comes up straight away with the operating system. Press return a few times, you can see that we're interacting with it. We can do the old-fashioned print 12 times 12. And we get a result. But better than that,
this is a basic?
This is not. This is a cross between basic and C. It's a functional language. The idea is that you write all your functions in text, you send them to the RAM, which is on the chip. When you're happy with that, you save the functions to flash, and then you've got them functions permanently in place. As I was just saying on this one, we've got an SD card on this particular device, which is a BP2. We can type DIR, and that's a listing of the files on this SD card. And the other functions and writing the programs is just as easy as that, really. Opening and closing files is no problem.
Okay. What other items have we got here today?
The other items I've got a smaller version of this BP2, which is the BP1. This is running the new RGB LCD display and controller. This controller is either serial or I2C, and it's got 3 backlight outputs, all of which are pulse width modulated, so you can control all 3 colours individually. This is connected to the cut down version of the Byvac, the BP1, and it's running a standalone program, as you see. There's another standalone program running this, which will operate these lights.
Very nice lights. Where do you get them from?
I got them from a guy called John from Shropshire. What this is, it's just an ordinary TV remote control. The TV remote control sends signals to that infrared detector, which detects whether I press 1, 2 or 3, and that sends a particular program to those lights.
That's a particular infrared device you've got there, yeah?
It is. It's a special device that works with these TV remote controls. It's very cheap.
Okay, what else have you got?
I've got the Raspberry Pi add-ons. One of the Raspberry Pi add-ons is this power supply. Here you can see a prototype power supply.
Very nice.
I've got the 5 volt output and the 3.3 volt output.
So this replaces the two main regulators, yes?
Yes, this replaces the USB cable that you have to plug in to get your 5 volts here.
Okay.
So you can plug anything into it, AC, DC, positive, negative polarity. It will transform that then into 5 volts, which is sent to the Raspberry Pi, and 3.3 volts, which is sent to the peripherals. The peripherals I've got on this board at the moment is a 1.2 amp stepper motor and DC motor controller. This is demonstrating that it's got a DC output, a DC motor output. That's just an old printer mechanism that's working. We've also got a stepper motor controller here. These are both stepper motor controllers. This is a 4 amp one. There's some Python software written up here.
Have you written this software?
Yes, and it's all free, available on site. So the stepper motor one, for example, press go, that will send 10,000 steps at 3,200 steps per second.
Okay.
So if we press go, we'll see the thing spin round. So that's spinning round the stepper motor. It's also connected to the relays, and the relays are connected to these lights. So again, we can turn the relays on and off via the Raspberry Pi interface. And again, the Raspberry Pi interface has got a dialogue. It's got a dialogue box here that controls the relays turning on and off.
And these are all written in Python?
All written in Python, all freely available. The relay has also got 3 analog inputs which the Raspberry Pi doesn't have. So they're quite useful as well. The 3 analog inputs are actually on the relay board.
What do you have those connected to at the moment?
Nothing. So that's why they're reading full, because they've got small pull-up resistors.
Okay.
So they're reading full on at the moment. The last thing that I can show you is how they all stack together. These stepper motors.
So you got your own stacking system, yes?
Got their own stacking system, yeah, where it's got serial, I2C, or step and direction.
So you can drive that either intelligently or with logic, yes?
Exactly. But I've also got these with the same stacking method. Now these you can buy as a kit. That is a kit that you assemble together yourself. One of them's an analog to digital controller, and the other one's a GPIO with pulse width modulated output.
Are these based on the microchip?
Yes, these are all based on microchip controllers. They're all pre-programmed, ready for the Raspberry Pi, and they work either serially or with an I2C interface.
Okay.
The last thing I've got to show you is this kit here. This kit is which again interfaces to the Raspberry Pi.
Yep.
With this, and it's the red, green, blue LCD controller. It will do 16 by 2 or a 20 by 4 or any other combination.
It allows you to drive a 16 by 2 with a serial.
Just
with a serial or I2C.
Well, right.
That's the I2C one. That's the serial one. And
if you buy the one you need, it doesn't do both.
No, you buy the one you need. And that's what I've got for you today.
Oh, thanks very much.
Well,
cheers.